Welcome. In this demo, we will walk you all through data science in a box, ProCogia's AI governance and enablement platform. Data science in a box is designed for organizations operating in regulated and high stakes environments that want to unlock the productivity of generative AI without compromising security, compliance, or control. What you're about to see is a secure, cloud agnostic platform that enables teams to work with AI, data, and analytics inside a fully governed environment connected directly to enterprise systems. Let's take a look. This is the ProCogia Data Science in a Box platform. It is currently built on AWS using Amazon Bedrock, a fully managed LLM service. This platform is not completely tied to AWS and will also run just fine on Azure. Azure offers a very similar service through Azure AI Foundry, and the platform can also run on Google Cloud Platform. All major cloud providers now offer fully managed LLM services. While there are differences in offerings and integrations, at a high level, this provides a way for you to access AI tools within a fully walled garden that is connected to your data, can be secured behind a VPN, is not open to the internet, and is authenticated using your preferred method of authentication. In this environment, authentication is currently handled through Cognito. After logging in, you are taken to the main page. The main page includes a number of applications that we have deployed and integrated. The first one we'll look at is a new conversation. The idea behind this, when we built it, was that people would log in and use AI tools in the same way they use ChatGPT to get their work done. It is such a powerful tool and a significant productivity boost for employees to log in and use it for whatever they need to do. On the other hand, data governance and IT teams understand that you cannot simply upload company intellectual property to a public website, which is exactly what happens when people use public AI tools like ChatGPT. So, the only way to make this work effectively is to build a system that is just as capable as what consumer AI tools have to offer. On the left hand side of the screen, you can see users have access to all of their previous conversations. These conversations are stored in an external database service using Aurora RDS. Users can upload a document and immediately begin interacting with it, just like they would with ChatGPT. They can also access a knowledge base, which is a backend RAG system we have built. This can include sources such as SharePoint sites, HubSpot, or HR platforms, and each connection can be authenticated individually. For example, if a CEO asked to link the HR system into this data source so that they could see which projects the user was working on that week, that information does not need to be shared publicly with the entire organization, so it was made available only to them. This platform does everything we need it to do, and it does so in a very intelligent way. One capability common across major AI platforms is what's called routed chat. When you interact with the AI, you are actually working with a suite of models. The first is an entry model, which is usually lightweight and cost efficient. You may have noticed that when you ask ChatGPT a question, it sometimes displays messages like thinking for a better answer or looking up current news. Those messages come from an initial routing model that determines what the user is asking and routes the request to the appropriate agent to fulfill it. In this case, we have configured the platform to route requests in three primary ways, all implemented programmatically. As a data analysis and data science company, this structure aligns well with our needs. We use a lightweight haiku model from Anthropic for general chat, workflows, and basic text generation. It is extremely cost effective and well suited for these use cases. If we prompt something simple, like tell me a joke, the system first routes the request, determines that it is general chat, and uses a lightweight model rather than a large one. It also includes any relevant links from the knowledge base. This post-retrieval process is built on a vector store hosted on AWS. It attempts to validate the information returned by the model. While this does not completely eliminate hallucinations, which are common in chatbots, it is currently one of the best tools available for reducing them. Users can download any reference files. In this case, we don't have any joke books in the knowledge base, so the relevance scores are low. This simply shows what the system checked on the back end to validate the response. Next, if we prompt something more advanced, such as tell us how to do a logistic regression in Python, the system again evaluates the request and decides that code generation is required. That request is then routed to a higher capability model, such as Sonnet 4.5, which after a few seconds returns the appropriate code. This experience closely mirrors what users are familiar with in tools like ChatGPT, Perplexity, Claude, or other AI tools. On the side of the interface, there are several indicators. One of the model is current context usage. Language models can only retain a limited amount of information in memory at a time. To manage this efficiently, the platform summarizes prior context to keep it compact. This is a cost-saving mechanism, as LLM APIs can be expensive. Users can also view 24-hour usage metrics to monitor their own activity and make informed decisions. All of this activity is tracked and stored. Administrators can build dashboards to analyze how the platform is being used, what types of interactions are occurring, and how routing decisions can be optimized for the business. Finally, there is what we call superbrain mode, which is an advanced reasoning model. This mode searches the internet to answer questions that require information beyond a model's training cutoff. Foundational models are trained on data available up to a certain point in time. For example, Opus 4.5 was released late last year, so it only includes information available at that time. When newer information is needed, Superbrain mode searches the web, evaluates sources, and scores the quality of its own response. If the response does not meet its confidence threshold, nothing is returned. This mode uses a cost-effective tool called Tavily and provides citations for all retrieved information. Users can review both internal knowledge sources and external web sources to validate results. This functionality is similar to what leading AI tools offer today, but it remains fully governable. In regulated industries or in situations involving public records requests, every interaction with the system is logged and auditable. We also offer additional features, including chat with your data. In this example, we're working with sample data. Users can view a database schema and interact with it directly using natural language. The system provides pre-configured prompts, summaries of available data, and an overview of the dataset. Users can then ask questions such as how many men and women are included in the data. Even if the schema does not explicitly label gender, the system interprets context to determine the appropriate variables and runs the necessary SQL queries. Results are returned in table form along with the generated SQL. This allows analysts to take the work further if needed, while enabling executives to get quick answers without relying on data teams for every request. We have implemented this capability for several clients and support complex joins, factor analyses, and advanced workflows using SQL or Python. It performs very well. The platform also includes an admin dashboard with role-based access. While there are few users in this local development environment, administrators can add services and enable features as needed. Authentication can be handled through SSO, allowing IT administrators to provision access centrally. Similar to tools like Slack or Jira, users authenticate once and are assigned roles within the application. Finally, the platform integrates with commonly used data science tools, including IDEs and publishing platforms from POSIT. Users can develop and publish applications and share them internally. All tools connect to the same backend LLM platform. Open source Python and R packages allow developers to interact directly with Amazon Bedrock or Azure AI Foundry, accessing the same knowledge base and background context available through the graphical interface. The knowledge base itself is stored in an S3 bucket on AWS. Uploading files with strong tagging and metadata is key to making retrieval effective. Metadata is parsed and tagged by a lightweight AI model, making files easier to find and use in RAG workflows. Currently, the knowledge base operates as a vector store. AWS has recently introduced knowledge graphs, which provide enhanced traceability. If required, the platform can be extended to support this capability. When files are uploaded, users may have many documents stored, but only personal files are visible to them by default. A separate store on the same S3 bucket contains shared sources such as company SharePoint data and other APIs. Personal files remain isolated to the individual user and stay within the secure walled garden we've built. To summarize, data science in a box provides a secure, governed foundation for enterprise AI adoption. It delivers the productivity teams expect from modern AI tools while giving organizations the controls they need around security, compliance, cost, and traceability. If you're exploring how to operationalize AI responsibly within your organization, ProCogia would be happy to discuss how data science in a box can support your goals.